Welcome to aminacademy.com. In strength of materials, let us discuss about polar moment of inertia of circular shaft. The polar moment of inertia is the measure of an object capacity to oppose or resist torsion when some amount of torque is applied to it on a specified axis. Suppose here solid circular shaft is fixed here. You are giving a torque at the end, so that resistance oppose the torque by using its resistance. That means its resisting capacity to twist is called a polar moment of inertia. The polar moment of inertia basically describes the cylindrical objects, including its segments also. Resistance to torsional deformation when torque is applied in a plane that is parallel to the cross-sectional area of its plane that is perpendicular to the object central axis. Now let us discuss further about polar moment of inertia. The moment of inertia of a plane area with respect to an axis perpendicular to the plane of the figure is called polar moment of inertia with respect to the point where the axis intersects the plane. In a circular plane, this point is always the center of the circle. Now, rho by r, the relation rho by r, already we have c theta over L. Let it be 1. And therefore from this and T torque equal 5 over 16 into tau into dq. This is equation 2. Now already we discussed about these two equations. Now from this or from 1 and 2 we can get tau equal to 16t over by dq. Substituting tau in 1. So 3. Substitute 3 in 1. We have tau equal to 16t pi dq. 16t over pi dq into r equal c theta over L. Now from here t over pi by 16 dq r because that means this 16 come as down of pi equal to c theta over L. Now look at here, t over pi by 16 dq, r is taken as d by 2 equal to c theta over L. Now this pi by 16 over the 2 is pi by 32, that is t over pi by 32 d power 4 equal c theta over L. Now pi by 32 into d power 4 is j, that is polar moment of inertia. Then t by j equal c theta over L, where j equal to polar mi, polar moment of inertia. Therefore, this is the result. T by J equal C theta by L. Note, for halo shaft having diameter D and D, capital D and small d, then J equal pi by 32 d power 4 minus d power 4. We have to use J for the halo shaft this. The term J by R is known as torsional sectional modulus. Now, J by R, not the true, J by R is called torsional sectional modulus. Torsional section, so torsional sectional modulus. Torsional sectional or polar modulus, or it's called a polar modulus. It is similar to section modulus with equal to I by Y in plane figure. Not in plane figure. This I by Y is the moment of inertia over section modulus. Therefore, this J by R is equal for solid shaft is pi by 16, which is equal pi by 16 d cube for solid shaft, and pi by 16 d cube d power 4 minus d power 4 over d for halo. Shaft. Now let us do one example problem regarding this concept. Find the angle of twist per meter length of a halo shaft of 120 mm external and 80 mm internal diameter if the shear stress is not to exceed 35 MPa, takes C equal 85 GPa. Now, length per meter, that is length equal to 1 meter given, and capital dia equal 120 mm and small dia is 80 mm and tau equal 35, that is shear stress is 35 MPa. 35 MPa is equal 35 Newton per mm square. C, modulus of rigidity, C equal 85 GPa, which is equal, gigapascal is 85 into 10 power 3 Newton per mm square. Now, these are the given things. Now, apply the torque formula. T equal this is a halo shaft. T equal pi by 16 into tau into d power 4 minus d power 4 over d equal pi by 16. The tau is 35 into 120 power 4 minus 80 power 4 over 120, which gives by calculation is 9.525 into 10 to the power of 6 Newton mm. Now next J, polar section modulus. J, we are calculating. J is J equal formula pi by 32 d power 4 minus d power 4 equal pi by 32 is 120 power 4 minus 80 power 4, which is equal 16.328 8 into 10 power 6 mm power 4. This calculation gives 16.328 into 10 power 6 mm power 4. Now the relation T by J equal C theta by L. Then apply T is 9.525 into 10 power of 6 over 16.328 into 10 power 6 is equal to C theta by L. C is modulus of rigidity 85 into 10 power 3 over 1. C theta by L is 1. 1 meter is 1 into 10 power 3 mm into theta. So common terms cut, and therefore theta is equal 9.525 over 16.328 over 85 equal 0.00686 radians. You have to convert this radian and degree, that is theta equal 0.00686 into 180 over 5 is approximately equal 0.4 degrees. We have done. Please subscribe our YouTube channel.